Hey, rate limiting your API endpoint is gotta be one of the best decisions you can make to prevent abuse. And trust me, man, APIs get abused for the stupidest reasons. Sometimes there are no reasons. Sometimes people just like to spam your API and to not go bankrupt because of it, especially if you do AI, right? Because AI is super expensive to run, as well as for any other public-facing API that you don't want abused. Rate limiting is the way to go. Is that right? You want to join us in rate limiting, yes? Okay, so we're gonna rate limit together with my cat today. Can you see her? She's, oh god, oh no. In this video, two things are gonna happen. First off, we're gonna rebuild one of the most popular APIs in the world, a JSON placeholder API handling like 3 billion requests per month. We're gonna rebuild the basics of that as an API to demonstrate rate limiting on. Sounds complicated, it's not, it's just a JSON API. And then we're gonna implement rate limiting together. Okay, so before we get to the inner workings of rate limiting and why it works, let's quickly see why would you even want to rate limit in the first place? Just why? And well, the basic idea is to prevent API abuse, right? If people completely spam your API endpoint, depending on what logic it handles under the hood, that might get expensive, right? If the platform where you host the API is gonna bill you a lot for all those requests, especially in serverless environments, well, then it's in your best interest to rate limit your endpoints, at least the sensitive ones that you never want spammed. So here's the basic idea behind rate limiting, okay? We're gonna start here. First off, we're gonna check the IP. So a user made a request to your endpoint. First thing we're gonna do is check their IP address and then check how many requests has that IP made. By the way, all of this is going to happen in our own database in this video. It's going to be pretty neat. You're going to see that later. And then we're going to do a check. Depending on how many requests they did, are they still allowed to make more requests? So for example, we could allow maximum 500 API requests per like 1 minute, for example, per minute, right? If we say that's our maximum, then we can enforce that maximum right here. And if the user already has made too many requests, well, then we're going to block the request. We're not going to let it through. In this case, we're going to send back a 429 HTTP error. You're making too many requests. Bro, stop it. Stop making so many requests. And in the other case, we're going to say, yep, everything is fine with your request. You're still under the limit of what you're allowed to do. So we are going to increment your request count so we can keep track of how many requests you make. But we are gonna let the request through and everything is okay. So the basic idea is we can enforce a limit per time on our API, a maximum request amount per time interval, like seconds, minutes, hours. And this is totally up to you, as well as the actual amount that you allow. Everything here is totally up to you. It's really just about enforcing those limits and making sure that you never get billed more from your API because somebody is DDoSing you, because somebody is abusing your API, manually spamming it, wrote a script to spam it, and so on. Because even if you don't think it can happen, it can, right? People are sometimes just, it just happens sometimes, even if you write like good software, if it's a fun project. It has happened so many times where I saw that people got their API spammed for no good reason. I mean, there's never really good reason, but for no reason whatsoever. Just some random dude spammed their API and it just resulted in some horror bill on Netlify, on Vercel, and so on. And it's just, it just sucks, right? It's just preventable. So what we're gonna do is learn how to rate limit to prevent this. And as a example, we're gonna use a JSON, or we're gonna write a JSON placeholder API together that is serving 3 billion requests each month. And we're gonna write this together and then rate limit it to learn how that works, right? And everything we'll do right here in our CMD. This is where we're going to start. This is going to be pretty simple. You're going to learn, hey, rate limiting is actually pretty simple and it's also fun to learn. So let's zoom in here and get started in rate limiting or API. I'm going to navigate over to my desktop because that's where I want the file to be. And I'm going to make a new directory and let's call this rate limited API. If you want, you can call it the same thing by following along here and hit enter. And then let's cd into the rate limited API and say code dot. And that's going to open up this folder inside of VS Code here on my left hand side. Okay, so once we are in here, first thing we're going to do is open up the terminal, and I'm going to zoom in so you can see everything here easier. First thing we're going to do is say npm init-y. Now we could just leave the -y away, but it basically says yes to all the default options, creating or package.json, right? This is going to be the basis for our API. And to set up our TypeScript config file, we're going to say tsc --init and hit enter, and that's gonna create our tsconfig.json. And just to make your life easier, I prepared everything here, of course, inside of a GitHub repository and also inside of a copy-paste list. So I'm gonna include something in the copy-paste list called the tsconfig. It's gonna be way up there, first item, and you can simply grab this tsconfig and paste it in here. This is not a TypeScript course, right? We don't really care about why this works. Basically, it just sets some targets that we want to transpile to, right? That we want to run our TypeScript from. Some best practices like the no unchecked index access, which is a really good idea to keep true in your projects, but it's off by default, and just generally to ensure some code quality in here. That's basically it, right? We can just copy paste it, no need to write everything here ourselves. Perfect. And then for the actual server, like the API endpoint, right? We're gonna create that inside of a index.ts file. This is basically the server that's gonna handle all the requests. Now, to create this API endpoint, we're gonna use a tool called Hono.js. I really like this framework. It's a fast, lightweight web standards following framework running on any JavaScript runtime, which includes Cloudflare workers, where we're gonna deploy this app, which is really fast and really cheap as well. And the syntax is just nice to write. So we're gonna use Hono for this. So inside of our project, let's clear the terminal and then say npm install or npm install or yarn add. Doesn't matter which package manager you use for this. And we're gonna say Hono and hit enter. Hono, by the way, if you're wondering, it has gained some massive popularity recently. Let me show you that. Let's navigate over to npm. You can see right here, 180,000 downloads. Wow, dude. That's a lot. It's been gaining a lot of traction, which is nice to see because the syntax is just really nice to write. And it's super easy to deploy this to Cloudflare workers as well. So to learn how rate limiting works, there's basically two steps that we're going to do, right? The first step is going to be creating the API. So it's publicly accessible, so people can request the data from the API. And then the second step, building on top of the first step, is going to be actually rate limiting the endpoints. Right, so first off, make the API publicly accessible, deploy it, and then secondly, make sure that it doesn't get abused and implement the actual rate limiting. And you're gonna be surprised, literally, how easy it is to set an API up using Hono. Let's do it together right now. Let's zoom in so you can see this easier. So check this out, right? We can say the const app is gonna be equal to a new Hono, which is a class. And by the way, pro tip, if you ever get that your auto imports in VS Code don't work, because right now it should work, right? It's a class we import from the library. If they don't work, hit Control, Shift and P and say developer reload window and hit that or hit enter on that. Right? That's gonna restart our VS Code instance. And now check this out. The auto imports all of a sudden, bam, like magic, they all of a sudden work. Which is really nice. And I'm gonna disable GitHub Copilot for this. Disable completions. They are kind of distracting. We don't need that. And let's implement the most simple form of our API. That's gonna be app.get. So whenever a GET request is made to the endpoint under / to-dos, right? That's what we are gonna call the API endpoint. In that case, we get access to the C, the context from Hono in the callback function, and can handle the request with any logic that we like. For example, by returning the c.json, which is just a helper, so that lets us return JSON pretty much. And then here we can say, for example, let's just say an empty object for now. We're gonna put something in there here in a second. And now to make this deployable, we can simply say export default app at the very bottom. And just like that, we literally wrote our first API. How cool is that? Now to preview this locally, we're gonna say npm install Wrangler, which is a tool made by Cloudflare that lets us easily deploy and also in development preview this application. So if we take a look at npm and go ahead to Wrangler, we're gonna see what it is, a CLI for all things Cloudflare workers. It's pretty neat. I use it a lot, especially when deploying to Cloudflare. It's by far the easiest way there is, with a quick start and so on. And it's like at 500,000 downloads per week, which is pretty solid. Right, so we're going to install that -d as a development dependency because we won't need that in production. And hit enter. And once that is installed, that shouldn't take very long, especially with pnpm, because pnpm is a very fast package manager. Let's go ahead into our package.json. And inside of here, we can define a dev script, dev to locally test out our API endpoint. And that's comma separate this from the existing test script. And in here, we're going to say wrangler dev and then the path to our server file, which for us is just index.ts. If you had a source folder, that would be source, like this, source/index.ts, but we don't have it. We just have it at the top level, so we can leave it like this. And then already try out if this works. Let's run yarn dev. That's going to say wrangler dev index.ts, and then it's going to start our server up on localhost. So if we just grab this endpoint, what do we expect to happen? Well, if we navigate to /todos, then we expect to get back an empty object. So let's verify if this happens. Let's navigate to the URL that Wrangler gave us and then /todos, hit enter, and there we go, perfect. Our API is running locally and we do get the empty object that we expected. So for example, if we tried anything else, like the message is gonna be hello, and then try that again, navigate back, reload, we're gonna get the message hello, meaning yes, our API definitely works. Very, very nice. Perfect. Okay, that's gonna be the basis for our API. And now we can actually start in writing our main endpoint. And what the main endpoint is gonna do is pretty simple, right? It's gonna be like the to-dos, but we will accept something a bit different. We will accept a / and then :ID. So the goal here of this syntax, right, is if we make a request to or api.com /todos/1, then we expect one to do as JSON to be output from our API, just like this, and just like the JSON placeholder example that I showed you in the very beginning, right? And to achieve this kind of syntax, in Hono, this is how we do it. Fully type safe, by the way, because we have this :ID in the endpoint URL. What we can do now is say const todo ID is equal to c.rec, which means request dot param as the singular, and then as the string we get full type safety. You notice that? How cool is that, right? Because we have the :ID right here, we get full type safety for the c.rec.param. That is beautiful, right? And the to-do ID is going to be something like 1 or 2 and so on, but still as a string, right? Because URLs are always a string. This 1, even though it's like a number, it will be received by Hono as a string. So we can convert it to a number, saying const to-do index is going to be equal to number to-do ID. And that's going to give us back basically the same thing, but as a number that we can now use to pull data from a local JSON file, because that's just by far the simplest solution. So let's create the data file, data.json, that our API will actually pull from. And this is going to contain nothing else than the actual to-dos that we want in our application, right? So if you know anything about JSON, you know we got to start with an empty object here, which is just JavaScript object notation, right? That's what it means. And inside of here, we can define something called to-dos. And these to-dos are going to be an array. We're just going to define 3 of them, very, very simple, and that we can use in our API to make requests. So the first to-do is going to be an object, and the ID property we're going to set to 0. This is the 0 index to-do. The title is going to be by groceries, and then the completed status is going to be false. So this is either very similar or actually the exact same thing as the JSON placeholder. We can go under /todos/1. I think that should work. Okay, so they also have a user ID in here, but basically same thing, right? This is the exact same thing that our API will also do with the data we define right here in our JSON file. As easy as that, right? And now let's define 2 more. So let's comma separate the next one, and we can simply grab all of the first to do and hold Shift, Alt, and arrow down, and bam, we just copy and pasted the same thing down in VS Code. Super handy shortcut if you didn't know it. The ID of the second one is going to be 1. The title is going to be walk the dog, and then the completed we can set to true, because let's just assume, yes, we already did that today. And let's do that one more time. Shift, Alt, arrow down, bam, copy and paste it down with the ID of 2. The title is going to be read a book, and we can set the completed status to false, because I have the reading comprehension of a 2nd grader and I'm unable to finish this task. We are done here, and now let's navigate back into our index.ts, because what we just did is set up the perfect basis for our API to now use this data. And if you're wondering, how do we import this JSON file into our API to be used here? Very simple, actually. We can say import to-dos as a named import from, and then ./data.json. As easy as that. We can import this JSON file into our API and now use it to answer the request made to our API endpoint, right? If you remember what the to-do index is, this is like 1, this can be 2, 3, and so on and so on. And now we just want to grab the corresponding item from our hard-coded to-dos right here. In order to do that, let's say const to-do is going to be equal to the to-dos at the index of to-do index that we already found out. And now the thing is, this could be undefined in case the to-do index is something that we can't use to access the to-dos. Like if it's any string, if it's 4, well, then there is no to-do at the index of 4, right? We will get an undefined to-do right here. So let's also say or an empty object. So we always return something, right? It's always an object. And that's literally it. We can now say return c.json and pass back the to-do from our API endpoint. And we can get rid of the old return statement altogether. Perfect. That is literally the most simple form of our API. And I think Wrangler should automatically reload, but let's just do this again. Let's clear the screen and let's say yarn dev to restart our local kind of API that we're hosting. And let's try this again. Let's navigate to localhost /todos/1, right? So this is the address that Wrangler gave us. It's under port 8787, and let's hit enter. And perfect, we get our to-do ID 1, title, walk the dog, completed, true. Perfect. We can also access the 0 to do and the 2 to do. Perfect. And if we type 3, then we're going to get an empty object because, of course, that to do doesn't exist. Perfect. Very, very nice. That is the basis for our API that we can actually go ahead and rate limit now. So the idea here is going to be that there's going to be a user and there's going to be your API. And let's say that you allow 2 requests to be made to your API in 10 seconds, right? 10 seconds. And then all subsequent requests made by the same user that we see by IP, by the way, is then going to be rate limited. So if they make 3 requests within 10 seconds, then the last request will actually not go through. It will be blocked. It won't ever reach your API. It will be rejected beforehand, and we will return a 429 status, which means too many requests, by the way. HTTP 429. Too many requests. There we go. That is the status code we're going to use to send back to the user to let them know that they are being actively rate limited, that they are making too many requests, right? So this is the idea of how it works. And implementing this is surprisingly simple. And to do that, we're going to head over to upstash.com because we're going to use their Redis database, an in-memory data store, to make this happen. And give me 1 second, I'm gonna log in here. There we go. That's gonna take us to the dashboard. Now, before we continue, I want to be very clear. I work at Upstash, right? That's how I'm able to do this second YouTube channel. I work here, but I work here because it's a product that I use personally for like the last 2 years, way before I started working here, and because it's just a genuinely really nice solution. Otherwise, I wouldn't be doing this video. So I want to be transparent to you. Yes, I work here, but I also think this is the best way to do it. And because we're going to use a Redis database, by the way, click the Create Database button under the Redis tab right here to get started with this. Because we're going to use Redis for this, which is an in-memory data store, well, this thing is going to be pretty fast, right? Compared to if we were using a relational database or something like that, which for rate limiting, in my opinion, doesn't really make sense. Can you? Yes. Should you? Probably not. Redis is probably the way better approach to do this. So I'm going to create a new Redis database together with you right now. Let's call this rate limiting. You can delete this after learning how to do this, right? This is just temporary. Regional is fine. We don't need a globally distributed replica database for this. We're just learning how this works, right? And as the region, we are going to say, let's say Ireland, because that's closest to me, and then choose whatever is closest to you, of course, and then hit create. That's going to prepare our database and give us the credentials right here under connect to your database that we need in order to connect to our database. Now, for the data that we actually care about, let's go over to the JavaScript tab, just because it's easy to see the values here. And oh, actually, no, we can go down to the REST API section right here. We can simply copy and paste these values, even better, right? Even easier. So what we're gonna do is first off grab the upstash Redis REST URL and hit copy on that. That's gonna copy it into our kind of, what is it called? Like the thing where you paste from. Like, dude, how can I forget the name of that? Like, dude, if I press Control V now, oh, the clipboard. Oh, dude, there we go, the clipboard. It will copy it to the clipboard. And we're going to put it inside of a .env file that we are gonna create at the very root of our project, so not in any subfolder, right? And this is where we're gonna say the upstash underscore redis underscore rest underscore URL is going to be equal to, and then simply paste in the URL we just grabbed from upstash. And same thing for the upstash redis rest token, right? We can simply copy the name for now, not the value, go into our project and paste in the name is going to be equal to, and then go back over, click the copy icon and also paste the value right in here as it is, and hit save on the .env file. And while we are here, we can do one more thing, and that is create one more file that's going to be the wrangler.toml. You already learned what Wrangler is. It's a tool for deploying to Cloudflare workers. And the thing is, in deployment, Cloudflare also needs access to these env values right here, but it doesn't have access to the .env file. That's a Node.js thing. So we need to declare these values separately in this file, right? So this file takes only a couple things. First off is the compatibility underscore date. And I just got this from the documentation. I'm not a wizard. I just don't know this automatically. You can just look up what the file needs. It's really, really simple. And we're going to say 2024-04-08. So it's a very recent release. And the name, this is what's going to appear in your Cloudflare dashboard, your project name for this. It can be anything. Let's call this placeholder -API, and because I literally already have a project named that, I'm gonna suffix this with -2, but you don't have to do that. This is just because I already have a project with that exact same name. And then as the vars, the variables, right? This is the environment variable stuff. We can simply go over into our .env file, grab everything in here, paste it into our wrangler.toml, and now one important thing is let's wrap these in quotes, right? In double quotes, the actual values. And I'm gonna space separate them from the equal sign just so it looks better. But that's important to wrap them in quotes. In the env, we don't have to do that. In the wrangler.toml, we do. Just syntactically, it's a bit different. All right, we can close out of the wrangler.toml, close out of the .env. We can close out of anything basically except the index.ts. Then we can also close the sidebar so our screen is not cluttered. Perfect. Okay, so now let's get started and actually rate limiting this endpoint. And the way we're going to start doing this is by first declaring a cache. Let's say const cache, and this is going to be equal to a new map. And that's already it, right? You're going to see why this is important in like a minute. I'm going to get to this, trust me. For now, let's continue with our actual rate limiter. So what we're going to do is write a simple class for this. So we're going to say class redis rate limiter, and then inside of this class, first thing we're going to do is declare a static instance, and this is going to be of type rate limit. Now you might be wondering, Josh, where does this type that we're using rate limit come from? And the answer is that Upstash provides a simple SDK over the Redis SDK, right? And it's called pm install at upstash/rate limit. So it's just a very thin wrapper around the actual Redis database, and also uses our own Redis database to rate limit people under the hood. Just a nice utility we can use to not implement all that logic ourselves, right? We can use it, we don't have to, but we are going to use it because it does save us time. And then once again, pro tip, if your auto imports don't work, click or hold Shift, Control and P, and then hit developer reload window. Might work for you, doesn't work for me. Let's restart the window, and then we should be able to import our rate limit type declaration right in here. And now we're gonna get into something called the singleton pattern. We're gonna declare this class once to later reuse it in our API, right? This is called the singleton pattern. I'm not gonna go too deep into it, and no, we don't want that. It's just a software development pattern. You're gonna see a lot in more like enterprise apps, I feel like, because it is more for performance optimization. Let's see, singleton is a creational design pattern that lets you ensure that a class has only one instance while providing a global access point to this instance. Sounds a bit abstract, but I think the image is all right. Basically, instead of every time our API is called, creating a new class, we only ever create one. Might sound a bit abstract. You're going to see exactly what this looks like. Let's just write code, okay? The static get instance, that allows us to reuse this instance is going to be a function, right? And this is going to get the context, and the type. For this context, we can simply hover over the C from Hono, grab this, and simply paste it here. Bam, there we go. We can import all the types from Hono, like the context, for example. We can import the .env type and also the blank input, right? That's it. That's how we do the TypeScript declaration, easy. And now for the singleton pattern. So if we don't have an instance, if not this .instance, in that case, we know we can create a new instance. But in the other case, to make this an actual singleton pattern, to never have more than one class instance, we can simply say return this .instance, right? So if we already have initialized this class once and then saved it in the instance right here, then we're simply gonna return it. No need to create a new rate limiter in that case, right? This is just a simple optimization thing. Honestly, you don't even have to do this, but I think it is nicer to do it. I want to show you the proper way of implementing this, and this is how you do it. So right after, we're gonna grab two things from our env, so from our environment variables, right? And to do that, we're gonna use the env helper that is provided to us by Hono from Hono/adapter. Right? And in here, this is a function we can invoke and pass it the C, the context. Now, to tell TypeScript what it is that we're grabbing from the env, because it doesn't know by default, how would it, right? We declare it inside of a completely separate file. It doesn't know that these values exist. We can tell TypeScript in the form of a generic what these values will look like. This is going to be the Redis underscore URL, and this is going to be a string. And then this is going to be the Redis underscore token, and this is also going to be of type string. And that allows us to simply type save, destructure these values from the function invocation right here. So we get access to these values and can actually work with them to create our Redis instance. Now for this Redis instance, we're going to install one little helper, and that's pnpm install at upstash/redis, which is basically the wrapper around Redis database access, right? If we go to upstash Redis, let me show you what this is. This is an HTTP based client to simply interact with our database. Damn, that's quite a lot of installs, by the way. Nice. Anyways, this is what we're going to use upstash Redis to access our Redis database. And then we can clear our screen and restart our development instance of the API. Now, what this allows us to do is say const Redis client, and this is going to be equal to a new Redis. And this Redis, once again, auto imports don't seem to work. That is fine. Let's restart our VS Code window, and that should fix the auto imports. And it didn't. Oh, it did. Okay, so Redis from upstash/Redis. However, one important thing that we need to change right now is by default, this will expect the upstash/Redis. This will expect a Node.js runtime. We're going to deploy this to Cloudflare workers. Therefore, we need to import the Redis from upstash/Redis Cloudflare and not the default import. And that allows us to now create the Redis instance. As the token, we're going to pass in the Redis underscore token. And as the URL, we're going to pass in the Redis underscore URL. Perfect. That means we can now access our actual Redis database to get started with the rate limiting. And now we want the utility for rate limiting that just makes it easier for us. Of course, again, we could do this all manually with the Redis client. We don't want to do that. We're going to say const rate limit is going to be equal to a new rate limit class that we're going to invoke. And in here, we're going to pass in our Redis instance that it should use under the hood, which is our Redis client, the limiter, and this is going to be a rate limit dot sliding window. This is the algorithm we're going to use under the hood to make the rate limiting happen. And this is where you define how many requests you allow in what duration. So for our example, we're going to allow 10 requests in the span of 10 seconds, right? That's how we do it. This string will be interpolated interpreted as an actual number by the library. We can just write it in natural language like this. And lastly, the ephemeral cache is going to be the map that we have defined. And basically, if we hover over this, we can see what this does. If enabled, the rate limiter will keep a global cache of identifiers. Basically, while the function is still hot, the rate limiter can block requests without having to request data from Redis, saving time and money. So basically, we are making sure that we benefit from the serverless environment. While this function is warm, this is going to exist and we can cache our values in here instead of using Redis, right? So it's faster, it's cheaper, it's just a good idea to do. You don't have to, right? You don't have to pass this, totally fine if you don't, but it's just a good idea. And lastly, we're gonna save this instance to this dot instance is gonna be the rate limit. And finally, return the this dot instance, right? So this is the singleton pattern I talked about. If there is no instance, we create exactly one and save it as the instance. And then the second, third, fourth time our API is called, we're not creating the instance again, but we're just drawing from the single instance that we created in the first invocation by just returning that instance and not creating a new one. That's why the singleton pattern is so nice. That's why we're using it. And now there's multiple ways of going about the actual rate limitation. We could do this on a per route basis, but a much nicer approach, much more reusable approach is the following. We are going to write our custom middleware for this. We're going to say app.use, and this is going to take an asynchronous callback function. And inside of this callback function, we get access to two things. The context, we're going to call C, and the next function we can invoke to actually pass the to end the middleware, to pass the request onto the actual API route, right? If you've ever written middleware, that makes a lot of sense to you. So the const rate limit we're going to define in here is going to be equal to the Redis rate limiter dot get instance. This is going to give us back our Redis instance if we pass in the context object, of course. That's going to return us the rate limiting instance that we can now pass on to any API route that we want by saying c.set, and we're going to set the rate limit to this rate limit. There we go, just as easy as that. And now to make this completely type safe, the cherry on top, right, because it does work in Hono, and we're going to go to the very top of the file, and we're going to say, or actually let's do this at the very top, right below the import statements. This is where it belongs. We're going to say declare module and then Hono. And inside of here, we're going to say, oops, we need to spell this, right? Declare, there we go. And inside of here, we're going to say interface context variable map. So this is something Hono provides to us that we can simply override to make the context, basically values we define in the middleware, and then make accessible in our API routes, in all API routes, because we did it in a middleware. This is where we can define the types for them to make this fully type safe, right? In this context variable map. And inside of here, we're just going to have one thing. That's going to be the rate limit of type rate limit. You can probably guess, right? And just like that, Hono now knows that we will make the rate limit accessible in our middleware that later allows us to use it in our actual API routes, all API routes where this middleware runs previously. And we can simply say now await next to pass on the request to the actual API route from the middleware. So basically what happens in a kind of visual way is we have our middleware, this first runs, and then our API route runs. But in the middleware, we actually, imagine this is the request, right? This is the rec, and this request is incoming from the user, bam, first the middleware runs, and the middleware now attaches the rate limiter, right? The single class that we have defined to this request, bam, it's on the request, and now the request goes on to our API route with the rate limiter attached to it, right? That's what the c.set is for. We are attaching it to the request to make it accessible in the API route, so we can now call this rate limiter in the API route. The reason we're doing this, we could also do this in the API route, defining the rate limiter here, but if we have multiple API routes, right, then the rate limiter will be accessible to all of them because it's on the request already, instead of us having to define it here and here and here, and every time you need a new API route. That's just not very reusable. This is a much cleaner way where it's immediately accessible to all of them. So that's what we're doing in a visual kind of way. To make use of this rate limiter, very, very easy inside of our API route. That's going to be const rate limit is going to be equal to c.get. And because this is fully type safe, now we get the rate limit string right here. And that gives us back our rate limiting instance that we created. And because we are rate limiting by IP address, by user IP, we also need access to that IP. And that's going to be the c.rec.raw.headers.get. And now we're going to get a header from the request that Cloudflare makes available to us, which is the cf-connecting-IP. Cloudflare gives us the IP of the user making the request that we can now use to rate limit that user. And to do so, we're going to destructure the success property from await rate limit dot limit. Right? It's as easy as that. And we can either limit the IP, or if the IP is for some reason null, right? If it's for some reason not available, we're going to say anonymous, so the person is still going to be rate limited, but ideally through the IP, and mostly that's always going to be there. And of course, in order to be able to use the await, we need to mark this callback function as asynchronous. Perfect. And now, what is this success value? Whether the request may pass or exceeded the limit. Okay, so what that means is if the success is true. If success, in that case, the user is allowed to make a request to our API endpoint. So in that case, we can simply copy and paste or cut the logic we already had and paste it in here. So only users that are below the current limit are able to get our to-dos. And else, in the other case, of course, the user is not allowed to make the request. They are already passed. This is like the third request if you allow two, right? It's too many. So in that case, we're going to say return c.json, and we're going to say as the message in here, too many requests. And to be kind of correct about this, we're going to pass the status as 429, which is the HTTP status for too many requests, right? You probably could have guessed. I told you earlier. Let's save this and let's see if this works. So we are right now allowing, I think it was 10 requests per 10 seconds. So let's try out if this works. We have our local server running. Let's restart it to make sure we are the freshest version. And then let's try this out in our browser by navigating to the to-dos and just reloading the page 10 times. So 1, oh dude, we get an error. Okay, so let's see what's the problem. Oh, and I think we misconfigured the env variable. So we get an error of starts with, and normally that is because we called the value in our .env file something else than we did right here. So right here we are expecting there to be a redis underscore URL, but I think in our env file, yeah, we called it upstash redis rest URL. So let's change that. Let's change this to redis URL, and then the token to just redis underscore token, like that. Hit save, and then let's restart our server, and hopefully that works now. And no, we get the same error. Okay, I'm gonna take a second to fix this and then let you know what the problem is. Okay, so the problem is these values right here in our wrangler.toml. Of course, these also need to be same thing, redis underscore URL, and then redis underscore token, right? So what we are expecting in our index.ts file. Let's stop that. Let's clear the screen and let's restart our development server, and hopefully that will work now. And it seems like I also did a typo with compatibility. This should be compatibility. Oh, okay, yeah, dude, English isn't my first language. Anyways, let's change that. It needs to be compatibility, and then we can see, perfect. Your worker has access to the following binding with the variables, exactly what we expect. And now hopefully if we restart our server, then there we go. And we actually get the data now. Perfect, okay. Now let's try this. This was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, perfect. There we go. Message too many requests, and we should get back a 429 error in our console. Okay, so 10 seconds have passed again, so I need to spam this again. There we go. Status 429, too many requests as the message, right? So let's click on this response message, too many requests. Perfect. Our rate limiting is working. And by the way, especially in the case of a DDoS where you get a lot of requests really, really fast, is every request gonna go to Redis and cost you money for the Redis instance? No, because we have a cache in here. We're basically utilizing the serverless runtime for our advantage, right? What I kind of teased about earlier, how this works, this cache. We're basically caching as much as humanly possible, so only what really needs to go through to Redis actually goes through to Redis, and therefore we can, even in a DDoS case where we get so many requests at once, remain very, very cheap and not go bankrupt because our API is getting abused, right? And as the last step we can do is, if you want, we can deploy this live to the web together, and we also do that using Wrangler. All right, so we can write a deploy script, and this is going to be Wrangler deploy -- minify, and we can pass the index.ts as the location of which we want to deploy. Now, it's automatically going to use the name that we defined in our wrangler.toml, which in our case is this one right here. You could, of course, also pass that as a flag if you wanted to, like -- name IDK, I don't know, just as an example, but since we already have it defined in our wrangler.toml, we don't need to do that. Great, and what's left to do now is to say yarn deploy. and hit enter. That's gonna run our deployment script and deploy this actually to Cloudflare workers. Assuming you're logged in, if you're not logged into Cloudflare workers, that's gonna ask you to log in, and then you can do the same thing. Basically, it uploaded our endpoint right here. It uploads the entire file and then gives us the URL we can use to access this API on the web. So let's paste this in, placeholder -api-2.josh-tried-coding.workers.dev, or it's gonna give you your URL, right? And then we're gonna go to /todos /1 and hit enter. We got the to-do, perfect. Let's retry this a couple times, and then we should get rate limited eventually. There we go, message too many requests, and then in the network tab, we can see that we get, well, now the 10 seconds expired again. We can make more requests because of the algorithm, the sliding window that we're using. But if we spam it too much, we're getting a 429 too many requests. Beautiful, man. And if you want, you can fully customize this to your wants. You can adjust the amount of requests you can make, or the user can make in the time frame. Totally up to you how you want to define that. You could even change this per API route, right? If you wanted different rate limitations. This is super flexible, whatever works for you. Awesome, man. I really hope you enjoyed this. That's it, right? That's as easy as it gets for rate limiting. I really enjoyed this, and it just works. Very, very nice to see. And I hope you enjoyed this video, following along, and learned how to properly rate limit your endpoint. So in case of abuse, in case of DDoS, you're covered, right? Because that's the main reason why we're even rate limiting our endpoint, so we don't suffer from API abuse. Very, very nice. Hey, I really hope you enjoyed this video and learned about rate limitation. This is a really simple example, right? We just returned JSON from a file. It's super simple, and I think it really well illustrates the point of rate. That was my cat. Anyways, I hope you enjoyed this as much as I did. Please stop doing that. And that's it for the video. You can use rate limiting in so many occasions in your Next.js app, in any other kind of serverless environment that you're in, and I really hope that you find this as useful as I do. Okay, that's gonna be it for me for this video. I'm gonna see you in the next one. Until then, have a good one, and bye-bye.